Welcome to today's lesson on ratio. I hope you will manage to download the worksheets and print them off okay, and also have a go at some of these questions on the starter page. We will start by going through these. This first one, solving this equation here, the goal of this question was to get u by itself, and to do this we have to solve equations by always doing the opposite and to both sides. You may lay it out slightly different to me, but you generally should get the same answer every single time. So the first thing that we should have done here is take away 9 from both sides, and that would leave you with 2u on this side because we've just got rid of the 9 by doing the opposite, and 10 on this side. Then our last step is to divide both sides by 2 because 2u means 2 times u, and the opposite of timesing by 2 is dividing by 2. So if we divide both sides by 2, we will get that 10 divided by 2 is 5, and dividing by 2 eliminates the 2 on this side, so we end up with u equals 5. Going over to the next question, very similar. The goal of this one was to get p by itself. The problem with this one is p is trapped inside this bracket, so the first step that we should have done is expand this bracket. And by expanding this bracket, we need to times everything in the bracket by what is on the outside. So we need to do 5 times 6p, which is 30p. And then we need to do 5 times minus 6, which will give you minus 30. And that is equal to still 330. Then it's the same steps as last time. We always do the opposite. You always do it to both sides. The first thing we should have got rid of here is that minus 30. The opposite of minus 30 is plus 30, which will leave you with 30p on this side because we've just got rid of that minus 30, and we have to remember to add it onto this side. It's just going to give you 360. Then it's the same as last time. 30p means 30 times p. The opposite of times by 30 is to divide by 30, and dividing by 30 will give you p equals 12. So the key to this question was to expand out the bracket first, and then it is just a simple 2-step solve equation. Moving on to the fraction question in the bottom left. The most common mistake students make with this question is they would just add the top and add the bottom and end up with 2 over 12. However, this is completely wrong. Remember, when we add fractions, we need a common denominator, which basically means the bottom number needs to be the same. So by looking at what we have a 5 and a 7. If we need to make these the same, we need to find a number that they both go into. That number would be 35. And how I've achieved that is by timesing this one by 7 and this one by 5. And you have to remember, whatever you do to the denominator, you also have to do to the numerator, which is the top number. So we need to do 1 times 7, which will give 7 on top. A very common mistake here is students make the bottom number the same, and they forget to make the bottom, they forget to times the top number, so they would have 1 here, which would also be wrong. So we have to remember to times it by 7, which will give you 7. And if we go ahead and do the same to this one here and times the top by 5, we'll end up with 5. Now we're allowed to add these fractions together. We are going to keep the denominator exactly the same, which is 35, and we can add the tops, which will give you 12. You should always try and simplify fractions, see if a number goes into both the top and the bottom. Here, we can't have any number that goes into 12 and 35, so this would be our final answer. Moving across to this one. When we divide fractions, there is a very important rule that you need to remember. A lot of students like to remember it as KCF, which means keep, change, and flip. So that means I need to keep this first one, change the second one, and flip the sign. So that would give me 4 over 5 times by, and I flip the last fraction, which is 7 over 3. Once I've done that, I can just times across. So that will give me 28 over 15. This is a top-heavy fraction, which we can turn into a mixed number by seeing how many times does 15 go into 28, which is going to be 1 whole one. And then how many are left over? How do we get from 15 to 28? That's going to be 13 left over 15. We cannot simplify this because 13 is a prime number. So, moving on to the lesson ratio. This is part 1 of a 2-lesson series. We'll talk first very, very briefly about what a ratio is, just to get you up to speed, or if you've forgotten, or if you're unsure. A ratio is simply a way to express two values compared to each other. So for example, if we look at this diagram here, we can see that we've got some counters. Generally, when you learn ratio at the beginning, you always start with some sort of balls in a bag or counters. Here we can see that we have got, if I just add another one, so it makes a bit more sense. Here we have got 1, 2, 3 pink counters, and we've got 1, 2, 3, 4 yellow counters. We would turn this into a ratio by writing the ratio of pink to yellow counters would be, well, there are 3 pink ones and 4 yellow ones. Here, what I like to do is add a total column, which we'll get to in the next page. And the total here is 3 and 4 would be 7. Okay, and this can work for any situation. You could look at this burger here. If I wanted to write the ratio of the bun to the burger, I could say that the bun to the burger would be, well, there are 2 parts buns to 1 part burger. Okay, and that would have a total of 3. Similarly, down here, if I have water and squash, if you make your drink in the morning, I could say that the ratio of squash to water, and you can be lazy, you don't have to write the full word out, you could just put the starting letter if they're not the same. Let's just say this is 2 parts to 6 parts. We could say this is 2 parts to 6 parts with a total of 8. Okay. We could also say that the water to squash is 6 to 2. And it's quite important, the way they word questions would determine which way your ratio is written. So if we go across, and if you have this printed out, you can follow along. The most important thing with ratio is knowing that it can be turned into a fraction. A lot of students always forget this, and it causes a lot of confusion when trying to do questions that require you to turn it into a fraction. Later on, when you get towards GCSE, it's such a big topic at GCSE that being able to know ratio inside and out, which eventually, hopefully after these 2 lessons, you'll have quite a good understanding of all the different aspects of ratio, will be very, very useful for your GCSEs. If you're not quite at GCSE level yet, it's really important that you get the fundamentals sorted now. So we'll look at now ratios to fractions. We can write ratios as a fraction in 2 different ways. So if we look at this first worked example, it says the ratio of P to Q is 3 to 4. The first thing I'd always stress for you to do when doing ratio questions is to write this in the way I was just writing my ratios a second ago, where they're stacked on top of each other with a total column. So we could say, and you can follow along, P to Q with a total is 3 parts to 4 parts. And that has a total of 7 parts. So before I've even looked at this question, I've taken the question with the ratio in it and turned it into a layout that I'm more comfortable with, which I highly recommend. From here, it asks us, what fraction is p? Well, p is 3 parts out of a total of 7. So the fraction of p, to answer this question, is 3 parts out of 7 parts, because we're talking about the whole. A lot of students here for this question would write 3/4, which is wrong because it's not talking about p to q, it's talking about what fraction is p of the whole. However, in this example below, we can see that the ratio of p to q is 3:4. So again, I'm just going to write this out. P to q with a total column is 3:4, again with a total of 7. But it asks what fraction is p of q. Well, p of q, we're not talking about the whole anymore, the total. We're talking about p of q. So p of q would be 3 parts of q, which is 4, so 3/4. You can have a quick go, and I'll give you 30 seconds to have a look at the ones on the right where it says your turn. I want you to do the same thing. I want you to write out the ratio with a total column in a nice format like that, and see if you can answer the 2 questions that it's asked you on the right. Okay, so what you should have written down is p to q with a total is 5/4, which has a total of 9. And it asks what fraction is q. Well, q is 4 out of 9, because it's not asking q to p, it's asking q as a whole, so it's going to be 4 out of 9. And this seems really basic, but it's going to build and be very, very useful for harder ratio questions. This one here, same thing, p to q with a total of 5/4, obviously a total of 9 again, and it says what fraction is q to p, or maybe that should have said of. So we can take this into a more worded example. So again, we're looking at ratios to fractions. If we focus on the worked example here, there's just a little bit more context to the question. The ratio of red balls to green balls in a bag is 2:3. What fraction of the balls are red? So what fraction of the balls are red? Well, first of all, before I even start, I'm going to write this as a ratio heading, which is red. So it says red to green. So I'm lazy, so I just write R to G. Always put a total in, because it can be very, very useful, and you'll see in further questions that it can be extremely useful. So the red balls is 2, and the green balls is 3. Why do I know the red balls is 2? Because it said red balls first, and the first part of the ratio they gave me is 2. So this has a total of 5. What fraction of the balls are red? Well, there are 2 red parts out of, well, it says the balls. All the balls, the total is 5. So it'd be 5, 2/5. So same thing. I'm just going to give you maybe 30 seconds to write down the ratio for this one under your turn, and see if you can answer the questions, which is very, very similar to the example I've just done. And then if you do that and you finish a little bit quick, you can have a look at this question at the bottom and have a little think about it. Okay, so you should have been looking at a very similar question here. The ratio of red balls to green balls with a total, always, and I cannot stress this enough, always put a total column in, is 2 to 5. That would give us a total of 7. This total is coming from me adding these together. What fraction of the balls are red? Well, there are 2 red parts and a total of 7, which would be 2 over 7. So looking at this question here, which is talking about the same topic but in reverse, so you have to have a very clear understanding of how these are working to be able to reverse it. Here it says the fraction of red balls is 2 out of 5. There are also green balls. What is the ratio of red to green balls? So the first thing that I would set up here is the ratio they've asked me, which is red to green. So I'll just put R to G and a total. So now we need to focus on this fraction and see how does this tie in with what we've just been looking at. Well, if we look at this previous example that you've just done, it says that the fraction of red balls is 2 out of 7. And if we link this up to the ratio above, we can see that the total is 7. So what's on the bottom of the fraction, in this case, is the total. And it's talking about red balls, and I can see that 2 is red. So if I take this in reverse down here, I can see that the total is 5, because it's out of 5 and it's talking about all the balls. So the total would be 5. And it's talking about red. So I can see here that the red would be 2. Okay, and that's how I've turned that fraction into a ratio. Now it's quite clear to see what should green be. Well, I know this total has come from this one and this one added together. So clearly here, green would have to be 3. So I can write in 3 there. So the ratio of red to green balls would be 2 to 3. Okay, so there are now 3 pages of questions that I would like you to have a go at. I'll start with the first one, but if you feel like you understand it, I'll start going through these questions, and then we'll move on to some additional stuff. So I'll just start with the first one, and then I'll let you continue 2, 3, and the rest of the pages. So in a bag there are blue sweets and red sweets. The ratio of blue sweets to red sweets is 5 to 3. So the first thing that I would always do, let's turn this sentence into something easier to look at. There are blue and red sweets. The ratio of blue to red, so blue to red with a total, is 5 to 3. The total here must be 8. What fraction of the sweets are blue? Well, there are 5 blue ones out of 8 sweets in total. So you can have a go at some of these other questions. If you're really not sure, I will be going through them in a few minutes. If you are sure, you've got a couple pages there to crack on with. But always set your ratio up before you start to answer the question. Read the question, look at what is it telling me the ratio is, and turn it into the ratio headings with a total. So this question, number 2, we should be looking at blue to red with a total, it's 2 to 7. And that has a total of 9. Then read the question, what fraction of the sweets are red? Well, looking at my ratio, there are 7 red ones out of a total of 9. So it must be 7 over 9. And these questions are very similar. In a bag there are blue sweets and red sweets. The ratio of blue sweets to red sweets is 4 to 9. So blue to red with a total is 4 to 9. That must be a total of 13. Then we can read the question, what fraction of the sweets are blue? Well, I can see here clearly there are 4 blue sweets. And if we're talking about all the sweets, we're talking about 13. So the fraction must be 4 out of 13. Okay. Moving on. And you can always go back. These videos will be posted onto the YouTube channel, so if you're unsure, you can always go back and rewatch them. In a bag, there are blue sweets, red sweets, and green sweets. The ratio of blue sweets to red sweets to green sweets is 5 to 3 to 2. So this here looks a lot more difficult, but it's exactly the same. There are just 3 parts to the ratio rather than the 2 parts we've been looking at. So again, same system. We've got blue to red to green. So blue to red to green with a total, and you always want to put a total in, is 5 to 3 to 2. So I can just write 5 to 3 to 2 underneath. And my total there, same thing. You just need to add up 3 parts now. So we've got 5, 3 and 2 makes a total of 10. Then we can read the question. What fraction of the sweets are green? So the fraction of the sweets that are green, well, there are 2 green parts out of all of the sweets, which is 10. 1 to 2, you could simplify that to 1/5. So very similar question now. 3-part ratio. In a bag there are blue sweets, red sweets, and green sweets. The ratio of blue sweets to red sweets to green sweets is 2 to 4 to 5. So that is blue to red to green. And again, if you're unsure how I know which order they go in, it says blue first, then red, then green. So that's blue, red, green with a total. Then I can write 2 to 4 to 5 underneath. To work out my total, I just add up my parts. So I've got 2 and 4 is 6, plus 5 is 11. Then I can read the question, which asks, what fraction of the sweets are red? So I'm looking at red and I'm looking at all of the sweets. So there are 4 parts of red out of a total of 11 sweets. So that would be 4 over 11. Okay, the next one, same. It's the same system. Blue to red to green is 6 to 9 to 4. So blue to red to green with a total, you always want to put a total in, is 6 to 9 to 4. And if I add up that to get my total, I've got 6 and 9 is 15, plus the 4 is 19. So we've got 19. Then I read the question carefully, and it asks me what fraction of the sweets are blue. What is 6 over 19? So even though these have got 3-part ratios, it is exactly the same system. The most important thing that you can get used to in this is the way you're laying out the ratio. If you're a little bit unsure about how this is happening, where I'm getting the fractions from, the most important thing that I want you to take away from this part is how I'm laying out these ratios. I'm laying them out, as the question said, with an extra total column. That total column will be very, very useful for the next part of this lesson. So moving along now, this is where it can get a little bit more tricky, because this is the reverse. So the example earlier, this one just here, where I was looking at it in reverse, is how we need to answer these questions. So I'll go through these. If you've already done them, you're about to see if you got them right. In a bag, there are only red and yellow sweets. 2/3 of the sweets are red. Write down the ratio of red sweets to yellow sweets. So the first thing we got to do here is they want the ratio of red to yellow. So I'm just going to write red to yellow. And again, I could write red to yellow. I'm just very lazy. It's easier for me to just write R for red and Y for yellow. And a total. I'm always going to put a total in. Now I need to go back and read this question carefully to see which number goes where. So it says 2/3 of the sweets are red. So 2/3 of the sweets are red. So how that works is the bottom number will always be the total. So that will be 3. So there are 3 total parts. And it tells me that 2 of them are red. So I can fill in 2 for red. Okay. Well, now I can see here quite clearly what would yellow have to be. Remember, this part of red and yellow added together gives me this total here. So clearly I can see red must be 1. A very common mistake students make here, they would write their answer as 2 to 3, which is completely wrong because the 3 does not represent yellow. 3 represents the total. So moving on to the next one. And again, if you're unsure, the more you follow along, the more you should be able to see what's happening. In a bag, there are only red and yellow sweets. 3/5 of the sweets are red. Write down the ratio of red sweets to yellow sweets. So they want red to yellow. So I'm just going to write red to yellow with a total. So I haven't done anything yet other than just turn that sentence into what I really want you to get used to, a ratio heading with my 2 parts and my total column. Now I can go back and read the question. In a bag, there are only red sweets to yellow sweets. 3/5 of the sweets are red. So we need to dissect that fraction as to which bit goes where. Well, 3/5 of the sweets. So the bottom bit, remember, will be the total because it says it's all the sweets. So the total will be 5. And the red, 3/5 of the sweets are red. So that 3 can go there. And again, once you've set it up nicely like this, it should be quite clear. Even if you didn't quite understand how I got that bit, you should be extremely clear on what yellow has to be to make 5. So yellow would have to be 2. Okay? Because 3 to 2 makes a total of 5 parts. So I'm just going to give you 30 seconds to have a go at that last one. If you haven't done it yet, have a go. If you have, I'll go through the answer in just a second. Okay, so again, reading it carefully. They want the ratio of blue sweets to green sweets. So blue to green, always put your total column. That's the most important part of this. The total column is really, really useful. If we didn't have this, you would end up with students writing 5 to 6, which is wrong. Having the total column and understanding what this denominator of the fraction means is the key to these questions. If we read this question carefully, it says 5/5 of the sweets, so that means 6 is the total, are green, which means 5 must be green. So if I put 5 underneath green, again, clearly here, hopefully you can all see, what would blue have to be to make this total 6? It would have to be 1. Okay, because 1 and 5 is 6. So that takes us on to the next part of the lesson. Being able to turn a ratio into a fraction is very, very important, because at GCSE ratio is everywhere, and often you have to be able to spot that you need to turn a ratio into a fraction to help you with lots of questions. So I will put up questions in the description. There are links to questions that you can practice by yourself after this lesson with answers to practice this topic here. So moving across, this now is probably what most of you are familiar with when it comes to sharing ratio. If I asked any student what's ratio, they generally say, add the parts together and divide. That's their go-to method. So we're going to go through that now. And I'm going to show you that it's not always just add the parts together. There's a lot more to it than that, because this section here, sharing ratio by the total, is just one small part of ratio. But it's the one that most people know how to do. So if we look at this worked example, Kate and Jack share 30 sweets in the ratio 1 to 2. How many sweets does Kate get? So again, the key to these questions is always how you lay it out. And this is quite a simple example, and I can see someone in the comments written the answer already. You can actually do these in your head a lot of the time, but what I really want to stress for you today is getting the system of laying out your ratio, so when the questions get a little bit more tricky, you can use that same method of laying it out to answer even the harder questions. So we're going to say that the ratio of Kate to Jack is 1 to 2. So Kate to Jack with a total is 1 to 2. And I can see I've got a total of 3. What happens now is you need to read the question and decide where 30 sweets go, because they're sharing 30 sweets. Now, if they're sharing 30 sweets, that's not how many sweets Kate gets. It's not how many sweets Jack gets. It's the total, it's how much they are sharing. Okay, so I can write underneath my total 30. Now, to really understand ratio, in this context of the question, this is my parts. Kate's getting 1 part, Jack's getting 2 parts. They're getting a total of 3 parts. This row here, where I've just filled in 30, is, in the context of this question, the sweets. Okay, so we need to fill in these. This is quite a simple example, but if I read down this total here, what does this tell me? This tells me that 3 parts equals 30. So we can write that. we can say that 3 parts equals 30. Sweets. You don't have to write sweets, but that's the context of this question. 3 parts equals 30. So what would 1 part equal? That's the key. The key to ratio questions is to find 1 part. Because if you know what 1 part is, you can see any part. Quite clearly, if I want to get 1 part, the trick is you divide it by 3, because what goes into 3 once? 3. The trick is you divide by how many parts you've got, and that will always get you 1 part. So if I divide the other side by 3, 1 part would be worth, and again, a lot of you might know this, and you might, oh, this is easy, but it's about the way that I'm laying this out, and the next 2 slides are going to be really a lot more challenging and really useful to have this layout. So that means that 1 part is 10. If 1 part is 10 sweets, this question is now very easy. Kate is getting 1 part, so she must be getting 10 sweets. Jack is getting 2 parts. Well, if 1 part is 10, what would 2 parts be? 20. And as you can see here, because we've laid our ratio out nice and clear, this makes sense. 10 parts and 20 parts equals 30 parts. Okay? So, that's how I want you to lay it out. I want you to give it a go on the next one. You probably can just look at the question and just say what the answer is. But the thing I'm interested most here is how you're laying it out. You don't have to write this bit here. That's just me illustrating. But this part and this part is really crucial to laying out ratio. So give that a go there. I'll give you maybe 30, 45 seconds to do that. Some of you might have already done it. This is very easy. As someone said in the comments, it is easy. But the next 2 questions is going to require this layout to make it as easy. So I'll just start setting this up. So what we have here, we have Kate and Jack share 80 sweets in the ratio 1:2. That means they have 1 part to 3 parts with a total of 4. If they're sharing 80 sweets, I can write 80 underneath here. Now again, remember, these are parts, these are sweets. This tells me, what does it tell me? It tells me that 4 parts equals 80 sweets. So what does 1 part equal? 1 part, well, if I divide both sides by 4 using the trick I mentioned earlier, how many 4s go into 80 would be 20. So 1 part is 20. Well, now this question is very easy. If 1 part is 20, Kate is getting 1 part, which would be 20. Jack is getting 3 parts, so 3 times 20 would be 60. And again, having a nice clearly laid out ratio shows me that 20 add 60 is definitely 80. Okay, so that's that. The layout is really important. Hopefully I can see some people writing in the comments that you got 20 as 1 part. So how many sweets does Kate get? To answer that question, she gets 20. To answer this one over here, how many sweets does Kate get? She gets 10, right? And we can see that from our ratios. If we go across to the next page, find the ratio given another part, okay? Now this is a little bit more difficult than sharing a total. Most students know how to do what we just did, but this is going to rely heavily on understanding how you lay out your ratio as to getting the correct answer. So if we looked at this work example, it says Andrew and Kieran share some money in the ratio 5:2. So Andrew and Kieran with a total, always put a total column, share some money in the ratio 5:2. So that must be a total of 7 parts. Okay, well, if we read the question, Andrew receives £30. So where would I write that? I would write that underneath Andrew, because it's how much he's getting. So I'm just going to write £30 underneath there. Not under the total, because they're not sharing £30. Andrew is receiving £30. This tells me that 5 parts is 30, so 5 parts equals 30 quid. And I'm reading that down. 5 parts is 30. So what does that mean 1 part is? Well, that means I need to divide both sides by 5 using the method I just explained earlier. So 1 part must be 6. How many 5's going to 30? 6. 1 part is £6. So how much does Kieran receive? £12. Okay, so £12 is the answer for that. If you really wanted to, we could fill in this total. There's 2 ways we can get the total. We can either add those 2 together, which is 42, or we can times this one, 7 parts, by 1 part, which is £6, which would also give 42. So have a go at that next one using the same method. Read the question carefully. Decide where the £30 needs to go. I'll do it silently. So if you're really unsure, you can just watch. But if you are sure, give it a go and I won't talk. So, hopefully you had something similar to that. Andrew and Kieran share some money in the ratio of 5-3. That's a total of 8. Andrew receives £30. So if Andrew receives £30, I need to write 30 underneath Andrew. That tells me that 5 parts equals 30. And we always want to find 1 part. 1 part is the key to the ratio. Because if you know what 1 part is, you can find any part. 1 part would be £6 because to divide both sides by 5 gives us 1 part. 1 part is £6. Kieran's getting 3 parts. So Kieran must be getting 3 lots of £6, which is £18. Good. And I can see people in the comments are getting 18, so well done. Excellent. So moving across to the one that most students always get wrong. Okay, this question here, or style of question I should say, all students struggle with when they first learn it. But by the way we've laid out our ratios, it should make it a lot easier to understand. And we're going to start exactly the same. So this is finding ratios given difference. So it's not what someone got, it's not what they're sharing, it's the difference. So, starting exactly the same way, Zach and Olivia share some money in the ratio 2-5. So that will be Zach, Olivia, total. Always laying it out like this. They're sharing it in the ratio 2-5, so the total must be 7. Okay, so that's our ratio laid out. We haven't actually done anything yet. We've just read the question and turned the sentence into a nicely laid out ratio with a total. This is the key. Olivia receives £30 more than Zach. Well, if she's receiving £30 more, it can't go under Zach because it's not how much Zach's getting. It can't go under Olivia because it's not how much Olivia's getting. And it definitely cannot go under the total because it's not how much they're sharing. The trick here is more. If it is more, we need to check how many more parts is Olivia getting than Zach. Well, Olivia's getting 5 parts and Zach is getting 2 parts. So how many more parts is that? That is 3 more parts. So if Olivia is getting 3 more parts and she's getting £30 more, we could say that 3 parts, the extra 3 parts that Olivia's getting, is equal to the £30 that she's getting more than Zach. And a lot of students really struggle to see that, but it's all about the way that they've worded this question, more. How many more parts is she getting than Zach? 3 more parts, and she's getting £30 more. So 3 parts is £30. Therefore, 1 part must be 10. So if we know 1 part is 10, now this question is very easy. Zach's getting 2 parts. So Zach must be getting 20 quid. And Olivia's getting 5 parts. So Olivia must be getting 50 quid. They get a total of 70 if you're bothered about that. But as we can see here, clearly, what is the difference between 20 and 50, £30, which makes the question make sense. £30 more, I can see they're getting £30 more. Okay, so have a go at the next one. I'm going to do it silently. And then after this, there'll be lots of examples for you to practice. Okay, so you should have written out your ratio like this. Zach to Olivia with a total is 2 to 5 with a total of 7. £15 more. Olivia receives £15 more than Zach. Well, if we check the parts, how many more parts does Zach or Olivia get than Zach? Again, it's an extra 3 parts. So 3 parts must be equal to the £15 more that they are receiving, which means 1 part must be £5. If 1 part is £5, it's nice and easy now. Zach is getting 2 parts, so that would be 10. Olivia's getting 5 parts, so that would be 25. Their total, if you're bothered about that again, not necessary for this question, but useful to fill in if you want to, would be 35. So that is a difference, and we can check if it works. They have a difference of £15, which makes our answer make complete sense. Okay, so there are a mix of questions now, 3 pages worth. Some of them are like the last example we just did, the difference. Some of them are like given 1 part, find another, and some of them are sharing the total. So I'll give you 5 minutes now to start them. Have a go. Focus on laying out the ratio like I've explained. It makes it a lot easier, and then I will go through in about 3 to 5 minutes. And maybe I'll just do the first one quietly. So the first one, the maths, was a little bit more tricky. You should have realised that £80 goes under the total. And that 5 parts, that tells me that 5 parts equals 80. To find one part, you divide by 5. Dividing 80 by 5 gives me that one part is 16. From there, if we know one part is 16, we can do 3 times 16 to get 48, and 2 times 16 to get 32. So Will would get £48, and Ollie would get 32. So hopefully the second one you should be very, very comfortable with. It's exactly the same as the last one. The only difference is there are 3 parts. So we've got Molly to Paige to Demi. Question 3 you might be looking at and thinking, what the hell is that? But I'll go through that in just a second. It's in the ratio of 3 to 2 to 1. So that is a total of 6 parts. Okay, so Ethan, you said you get the first bit but not the last bit. I'll go through the last bit on this question now. So if this question says they share 42 sweets, that would go under 42, under total. So this tells me that 6 parts, remember these are the parts, and these are, in this context, the sweets. 6 parts is 42. So if 6 parts is 42, I need to find one part. One part is very, very useful. So Ethan, if I want one part, I need to divide 6 by 6 to get 1, because 6 goes into 6 one time. I have to do exactly the same on the other side to keep it equal, because it's an equation. How many 6s go into 42? 7. So that means that one part is worth 7 sweets. If one part is 7 sweets, 3 parts would be 3 lots of 7. So 3 lots of 7 would be 14. Paige would be getting 2 parts, so that's 2 lots of 7. Sorry, that is not 14. That is 21. 2 lots of 7 would be 14. And then Demi's getting 1 part. We know that 1 part is 7. And you can always check to see if you got it right, because what should that add up to? 42, which it does. So what I'm going to do is 2 more questions, and then I'll leave you to finish those, and I will link the answer or the answers to the questions that I've not gone through in the video description below. So this one says ABC is a straight line. The length of B to C is 3 times the length of A to B. So this can really confuse students, but if we read it carefully, it says the length of B to C, so the length of BC, is 3 times the length of AB. Okay, 3 times the length of AB. So this part here is 3 times this part. So the trick here is you need to call A to B 1 part, and if B to C is 3 times A to B, well, what would 3 times 1 be? 3. The reason I chose 1 here is because it's easy to multiply by 3. So if I put 2 here, if it's 3 times more, what would this be? 6. So no matter what number you put here, as long as you times it by 3, because it's 3 times bigger, it would work. 1 is a nice easy number to use though. Once we have got that written out on our line, we can see that the ratio of A to B to C, so A to B to C, so what that's saying is A to B, which is this bit, to B to C, which is this bit, with a total, is in the ratio of 1 to 3. So I can see that my total is 4. Okay? So again, that is, out of everything we've done today, this is probably the most confusing because you have to turn this little diagram with this sentence into this. But hopefully you can see how I've done that. A to B is 3 times, sorry, B to C is 3 times A to B. So if this is 1 and this one is 3 times more, it must be 3. Then I can set my ratio up like this. Now we can get to answering the question using the same method. A to C is 80 meters. Well, what's that telling me? It says that A to C, this whole line is 80. So where would that go? Well, it's not talking about that bit or that bit, it's the whole line. So the whole line is a total, look. So the total is 80 meters. What does this tell me? 4 parts equals 80 meters. If 4 parts is 80 meters, we can find the value of 1 part by, again, using that unitary method where we can divide by the number in front of the parts to get 1. 80 divided by 4 is 20 meters. So if 1 part is 20 meters, well, A to B is only 1 part, so that's nice and easy. That would be 20 meters. B to C is 3 parts. Or if 1 part is 20, 3 times 20 is 60 meters. And you always know, the way I've explained about setting up these ratios, you always know if you're correct, because what is 20 add 60? 80. Okay, 20 add 60 is 80, therefore it must work. Okay, so the last question that I would like to go through would be question 8. So you can have a go at these on your own. I'll put links to the answers in the description. But let's just focus on 8, because there's a little bit more to 8. So Alvin and Simon shared £540 in the ratio 4 to 5. So Alvin and Simon, with a total, share the ratio 4 to 5 with a total of 9 parts. They're sharing 540. So you should ask yourself, where does that go? They're sharing 540. Does it go under Alvin? Does it go under Simon? Or does it go under total? Clearly, it goes under total, 540. Then you read what you can see. 9 parts. Remember, these are parts. These are pounds. 9 parts is 9 parts equals £540. Okay, so if 9 parts is £540, you should be able to now continue that question by finding 1 part. Okay, so hopefully you can fill in what Alvin and Simon get, and if you read the question, there's a little bit more to it. So 1 part, hopefully you found 1 part is £60, because 9 into 54 goes 6, so 9 into 540 goes 60. If that's £60, 1 part, that means Alvin gets 4 lots of £60, which would be 240. And Simon is going to get 5 lots of 60, which is 300. Again, it's obvious. We've got it right, because these two add to make the total we were given. We haven't answered the question yet, because it says Alvin gives half of his share to Theo. Okay, so Alvin gives half of his share to Theo. So how much does Alvin give to Theo? Alvin gives to Theo half of his share. So half of 240 would be 120. Simon gives a tenth of his share. So what does a tenth mean? It means you just divide by 10. So Simon has got £300 and he's given a tenth away to Theo. So a tenth of 300 would be £30. The question says, what fraction of 540 did Theo receive? Well, what did Theo get? Theo got £150 in total off of Alvin and Simon, out of 540. And that is the end of that question. So there was a little bit more to that, but as you can see, using the nice layout of ratio gets you to the crucial bits of information you need, and then it's just a case of halving Alvin's and dividing Simon's by 10. Okay, so that will conclude that lesson. I'll put the links to the answers to the rest of them in the description. There's also links to other questions that you can practice using this layout. The next ratio lesson will go more in depth on combining ratios and look at some more GCSE style exam questions. So if you check the website, you can see which year groups and which abilities I think that's appropriate for. Thank you for joining in. Hopefully you learned something, and I'll see you in the next one.